Oh, hello friends. Today we are going to look at nested loops and we are going to use matrices example. So we are going to use this program to write a C program that will compute the sum of any two matrices of any order and output the result in a matrix format. So for this case, we shall have to use nested loops. We shall have to navigate into nested loops and come up with a program that gives us the required output. So we shall have to open any compiler you're using, and for me I'm using a Visual Studio Code. So I'll open it and create a new file under this project called C programs. So I'll create a new file called matrix.c, and it will take me direct to the edit window. So I'll include my standard input and output library std io.h, and I will go direct to the main program into main. So I'll have to declare the variables that I'm going to use in form of some of them are going to be integers. Yeah, I think all of them. So we are going to need a variable that contains rows. We call it R. The second one is going to be called C. That one is for columns. Then the other one is going to be the variable that is going to contain our first matrix. That's called AI. So it's going to, the matrix array, like the dimension is going to be up to, let's put 100 there and 100 in this. Then the second matrix is going to be of size 100, like the furthest you can go. And then we shall have the sum of those two matrices in matrix format. Then you terminate. Oh, now we shall have to be with we shall need an we shall have to use loops in order to enter our matrices. So we shall need values of I and j, because our matrix is going to be in the form, or our matrices are going to be in the form AI, like AIJ, A11, A12, A13, A31, like that. So for this case, if you're to look at an example of a 2 by 2 matrix, it's going to be A11, A12, A21, A22. That's why I need I and J, AIJ, A11, like that. So I'll use I and J. So I'll prompt the user to give meaning to my program. I will say that this program computes the sum of any two matrices of any given size and then we shall have to enter the number of rows and columns for those two matrices. So a new line, enter number of rows, enter number of rows, and we scan it from the keyboard using the scanning function, which is data type %d, and we store it in the memory address of R. Then we enter number of columns, enter the number of columns and then scan it from the keyboard. So data type integer and store it in the memory location of C, that variable that we declared up. Now after entering the number of rows and columns, we shall have to enter the matrices, the two matrices. The reason as to why I declared the first matrix as, or each matrix as A with two arrays is because we are going to use two-dimensional arrays or a multi-dimension. So for that case, we are going to use nested loops. And nested loops mean that within a loop we have other loops. So for the first case, it will be for I equals to 0. This is an indexing set. Indexing set from I equals to 0 to I less than R, and then the other loop, like it will consider Aij, A11, A12, A13, like that. So another loop will be from I from J equals to 0 to J less than C, and we have to put an iteration of plus J, and here we forgot to terminate and put an iteration of plus I. So you open curly brackets. What should we do next? We have to enter the elements of the matrix A. So the first matrix, like you can see here, the first matrix, assuming that it's a 2 by 2 matrix, we shall have elements A11, A12, A21, A22. So now for that case, we shall have to enter them. So for the first one, we can enter, before going to the loop, we can enter elements of the first matrix. Enter elements, or enter the first matrix. Enter the first matrix and terminate, then go to the loop. So what we should put inside here, we shall be printing, we shall be entering the elements of the matrix A, Ai, Aij, like that, Aij. So we shall be having those elements, and then refer to I plus 1, because I starts from 0. So we have to start from A11. So to modify that, we should add a 1, the variable, and J plus 1. So that's Aij, then terminate. So then we scan those numbers from the keyboard. So the percentage D, which is an integer, and store them in the memory address of Aij, then terminate, and then we have to enter the elements of the second matrix. So we are going to enter on a new line, enter the second matrix, and then terminate the second matrix. So each one has to go to the new line here. So we are going to enter the second matrix. So we shall need a nested loop, a for loop within a for loop. So our J our I will start from 0. I will start from 0 up to row. Then we shall put an iteration of plus plus I, and then you put curly brackets and put another loop inside this for loop from j equals to 0, terminate up to j less than c, which is column plus plus j. Then we are going to enter the elements of that matrix, which is each element is going to be on a new line, and each element is going to be called B. Like here, you can see matrix 2 has B elements, Bij, B11, B12, B21, B22. I've just used an example by two matrices. Now, you have to enter them, B percentage D, Bij, and then store or refer to I plus 1 and j plus 1, because our indexing set starts from 0 and we want A11 or B11, B12 like that. So after that, we shall scan those elements from the keyboard. So we scan them from the keyboard, that's percentage D because they are integers, and then store them in the memory address of Ij. It's a two-dimensional array, Ij, terminate. Yeah. So now, after that, we shall add our two matrices. So adding the two matrices, we shall get adding the two matrices. So we are going to add two matrices, but still using nested loops. So for I starting from 0 to R, and then I plus plus, then another loop within a for loop for j starting from 0 to j up to c, then plus plus j. Yeah, there we are. So now we shall add these two matrices. So it's called the sum. Remember, we had the sum. The output matrix is called the sum. You get it? So now when it's adding, it will consider A11 plus B11, A22 plus A12 plus B12, A21 plus B21. So now let's go on and add. So the sum of Ij, so the sum of Ij equals to Aij plus Bij, then you terminate. So that's a nested loop which adds the two matrices. So after that, we are going to print the results. So printing the results. So now we shall need a loop, still the same loop. So for I starting from 0 to I to R, then plus plus I, and then plus plus I, and then the other loop is for j. So from j starting from 0 to j up C, then plus plus J, plus plus J, so within this loop, we are going to, this is a way of printing our results in a matrix format. So we are going to do it in such a way that if I or if J is the same as the number of columns, then go to a new line. So if so we are going to print them. So print f. We are going to print percentage d because they are integers, and yeah, we refer to sum ij, you terminate, and if we reach the end of the column, we should put the other entries where they should be on a new line. So if j plus 1, because remember j starts from 0, but if we add a 1 at the end, then it should be equal to the number of columns. So if j plus 1 equals to c, then we should do something. Then we should print those numbers on a new line. So should print them on a new line, then terminate. Yep, there we are. So this should be the results. We are printing the results. So for this app, remember for the first matrix, we didn't show the user that we are entering the second matrix. So we only did for the first matrix, so we can add that. So enter the second. Oh, sorry. See, let me see if we added that. Yeah, very well, we added it. So here we shall just say that these are the results for. So we print f, and on a new line we print f, and on a new line these are the results. Oh, the result terminate, yeah, and the results should go to a new line. Yep. Then after that, we tell our compiler that you know what, we have stopped. Yeah, so let's run this and we see. Control Alt N. Yeah, it will take some little time. Take some little time compiling. So here we are. So this is a program that computes the sum of any two matrices of any given size. So it is prompting us to enter the number of rows. Let's try a 2 by 2 matrix. Enter number of columns 2. Enter the first matrix. We can try using 1. A11 is 1. A12 is 2. A21 is 3. A22 is 4. Then enter second matrix. A11 is B11 is 4, B12 is 3, B21 is 2, and B22 is 1. So you see the result is there. The result is in a matrix format, 5555. Yeah, thank you for watching.